So let us understand the hardware part of interpret processing. Just you have to understand here that the steps you have to understand here. That's it. So first we know the interpret signal would be given to the processor. Okay, and that is the interpret request signal is given to the processor by the IO module, right? And how we are going to give it, I have already discussed through the interpret control line in the previous video. It's discussed. So the interpret request, first step is this: the interpret request, that is IRQ, is given to the CPU through this interpret control line, which is line of the system bus. Now CPU has this pin, that is interpret pin is there in CPU, that can detect whether an interpret occur or not. But we know CPU is executing, like let's say if it is executing program A, and when interpret occur, only after the execution finishes, only after the complete execution of this program A finishes, then only it will be able to go and handle the interpret. So the thing is that only after, if it is doing this instruction, let's say the currently, after complete addition only it will be able to go and check the interpret. If it doesn't do that, what happen in the mid instruction, if it is happening, what happens is that if the mid instruction, if it is going and checking the interpret, then this would result in what? CPU corrupt. Okay, this would result in CPU corrupt. CPU's internal state becomes corrupted. So in order to prevent that, only after the completion of the complete instruction, then only we will be able to go and handle the interpret. Now when now what after executing an instruction, the CPU would test, the CPU would test the interpret control line and see if it has any interpret and find the device from which the interpret occurs. So it would test the interpret line and detect a pending interpret. Then it would identify which device caused it. Then it will send acknowledge signal to the device. Only after sending this acknowledge signal means it will tell the device that I have got this interpret. Then only this IO device would remove IRQ, that is interpret request, from its IO module. After it has received this acknowledgement from the CPU, then only the IO device can remove its interpret's request signal. Understood? Now we know it was before doing this interpret service routine, that is before working on this interpret routine, it has to preserve its current program counter's value and also PSW, that is the current, it was executing some instruction. So if it has to perform next instruction after executing the interpret, the current program counter's value and PSW value has to be preserved. PSW means it includes the flags, interpret enable or disable bits, the priority level, processor mode, whether these things are the contents which was there. PSW is like a special register which is having these kind of contents in that: conditional flag, interpret enable or disable bit, processor mode, priority level. These are the contents which is there in PSW. These things it will what save. Now where it is saved, a stack would be made. After interpret, this stack would contain the program counter value and the PSW value. Now we have saved the program counter value safely. Now we have to next do is what? Interpret service routine. It has to perform. Now the program counter, in the program counter, that means the next instruction that we have to do is what we have to perform is instruction that you have to perform is interpret service routine. So the program counter have to load the address of this interpret service routine's address. But from where I can get this interpret service routine's address? In an interpret vector table. This interpret vector table contains each of the devices interpret service routine and their address. This interpret vector table, the address of each of the devices interpret service routine, which is present in the main memory. From there I would take the required interpret service routine address and I will load it into the program counter. So I will just repeat the steps. The final step that you have to understand is that first the IO device would raises and interprets request raises and interpret request to the CPU. The CPU would detect it using the CPU interpret pin. Okay, it will detect this IRQ. Now, after completely finishing the execution of the current instruction, it will test the IRQ which was there in the interpret control line, and it will identify from which device it is coming. Then it will send acknowledging signal to that particular device. Then it will clear that, the device would then clear its IRQ after that. Then we have to push the PC and PSW current the return address and CPU data. PSW, why we are, PSW contains the flag, the processor's mode, the priority level, and whether interpret enable or disable bit. These all are the information which is there in PSW. These informations are talking about the CPU status. These things and the stack pointer would be updated automatically, are saved into the stack. Then we have to load from the interpret vector table. I will get the ISR address which I needed, and I will load it into the program counter, right? Then I am going to next do is that this was my hardware part. Now I am going to do the software part. So in the software part, it will, now the software part is going to come. So what is happening in the software part? In the software part, the interpret handler would save the content. So first, interpret handler, what it will do, it will save the content of all registers on the stack, right? That is not only PSWs, and that is in the stack we told till now PSW and PC's value, but not only that, in the stack also the CPU registers, which is contents of all the registers, would be placed in the stack. So there was a figure there, that is there in the text. User program was running, last completed instruction was at location n, next instruction is location n plus 1. So address n plus 1 and all register contents are pushed onto the stack, and the stack pointer is going to get updated at the top, and PC is updating to where the ISR address, to the ISR beginning. After all these things are saved, we know PC now changes to what? ISR address. We know that PC's now new value is the ISR address. The previous values are saved in the stack here, right? Now why this n plus 1 is what discussed here. There was a figure that we haven't discussed. This figure we have to learn. Okay, in this figure the PC's value is saved here as n plus 1 because our last running program was at location n. So the new program would be at n plus 1. That is why it is saved here n plus 1. Okay, fine. So these are the things which are there in the stack. Now interpret handler processes the interpret. That means ISR activities would now happen. That means it will examine the status register of IO device. Was the operation successful? Was there any error? And it would read that data from, first it will do is that in the data register we have the data, and first it will see the status register of the IO devices, whether it has done successfully, is there any error and all. Now it will read the data from the IO module. If it is input, it will read the data from IO module, transfers that data to the memory location, send additional commands if needed, ready for next data block, or acknowledge any additional commands is needed, that is also given. Update the system's data structure. Mark this system data structure updation means it will mark IO operation is being completed and wake up any waiting process. This is a core process of the entire interpret. Now ISR activities are done. In ISR activities, first it will check the status register of the IO device, whether the IO operation has been done successfully or not. And if it is input operation, it will read from the data register and transfers the data to the memory location. Along with that, may it also send some commands also if it is needed. Like it may be like commands like acknowledgement, acknowledged error condition, ready for the next data block, like that. And finally, it will update the system data structures. That means it will mark the IO operation as completed and wake up any other waiting process are there. You have to wake it up. Okay. So along with the data, some commands, additional commands if needed, and finally updates the system's data structure. Fine, ISR activities are done. When interpret processing is completed, the saved register values would be retrieved. These were the now these we have to restore. Okay, these saved registers values will be restored from the stack will be restored, and it is putting to the registers back. After restoration, all the registers would contain the same value it was previously. We will pop all of these things registers value from the stack, and now the registers has the values it was before the interpret service. So this is interpret service activities are finished. These are the interpret service activities. There are 4 steps in the interpret service activities. After that, the CPU registers are basically popped out from the stack, and the registers value was how it was before this interpret service occur, before interpret occur. And then finally we will restore the PSW and program counter values from the stack. Finally, the stack now will be completely restored to the pre-interpreted state PC n+1. Now this in n+1 instruction at n+1 will be getting executed, and PSW is equal to original means all flags and all mode and priority will be how it was before. Understood? So CPU hardware, we have said interpret request would come from the device. The CPU will check that interpret request. It will receive this interpret request from the device, right? The hardware part was what? Device issues an interpret signal to the processor. The processor would finish execution of one particular instruction. Then it will test the test the interpret is there or not. Then it will send acknowledge it to the device. Then it will push PC, that is n+1, to the stack, and PSW to the stack, and load the ISR address to the load it to the PC. Then hardware part was what? It will push all the register, it will process the interpret. Then after processing and all is finished, it talk to the processing interpret. After basically after the processing and all is finished, here if you see, after processing is finished, then the registers are basically popped out of PSW and pop the PC value, right? That is how the main cycle is basically happening. Fine. Now we have to understand this diagram here. Okay, then we will do in the next video. Thank you.